Good morning, viewers. Today we are going to discuss about nonlinear data structures, tree ADT, tree abstract data type. It is in Unit 3 of Data Structures, CS8391. The objectives of this presentation are learning about the basic concepts, basic terms behind the tree data structure and the different types of tree data structure. So what is tree? As I told, it is a non-linear data structure. Hope you remember the difference between linear data structure and non-linear data structure. In linear data structure, the elements are stored in consecutive memory location. But in non-linear data structure, you can store the values in random location. So tree is an example for non-linear data structure. It consists of the root node and it can have many levels of additional nodes. They form a hierarchy. So we have the root node and the left subtree and the right subtree. Okay, so this is an example for tree ADT. What are the basic terms in tree ADT? First, what is called as root? It is the topmost node in the tree. So we have the tree. Could you please tell me which node is the topmost node? Yes, it is very right. It is A. So A is the root node. Then parent. The node which has a branch from it to any other node is called as a parent. Okay. So if you have a branch from that node to any other node, then that node is called as a parent node. Or you can say that if the node contains one or more children, then that node is called as the parent node. From the given tree, you can say that A is the parent of B and C. Can you tell me the parent of K? So it is G. What about the parent of I and J? It is E. Okay. So that's about the parent of the tree. Then child. The node which is a descendant of some node is called as a child node. Okay. From the given tree, you can say that C is the child of A because it is descendant node of A. So C is the child of node A. Similarly, B is also a child of A. And D is a child of B. K is a child of G. Siblings. Nodes which belong to the same parent are called as siblings. Okay. So in the given tree, the nodes I and J both are having the same parent E. I and J, the parent of I and the parent of J is E. So you can say I and J as siblings. Similarly, the nodes G and H, the parent of G and H is C. So you can say G and H as siblings. What is called as the tree? Tree of a node is the total number of children of that node. For example, in the given tree, the degree of B is 3 because it is having 3 children. Okay, that's why its degree is 3. What about degree of C? It is having 2 children. So degree of C is 2. What about the degree of A? So A contains 2 children, B and C. So the degree of A is 2. Okay. Hope you understood what is degree. And what about the leaf node? A node that has no children. Okay, a node that has no children is called as the leaf node or the terminal node. For the given tree D, I, J, F, K, H, all are leaf nodes because they don't have any children. Then what is path? A sequence of consecutive edges is called a path. Okay. Can you tell me the path from the root node A to I? So from the root node A, I can reach D, then D to I. So this is the path. A to D, D to I. Similarly, can you tell me the path for J? So from A, I'm moving through the edge, A to C, then C to G, then G to J. So this is a path. So path is a sequence of consecutive edges. What is ancestor node? The ancestor of a node is any predecessor node on the path from root to that node. Okay. The root node does not have any ancestors. Okay, the root node does not have any ancestors. For example, consider the given tree. The nodes A, C and G, they all are the ancestor nodes of the node K as well as the node J. Okay. So now can you understand what is ancestor node? It is any predecessor node on the path from root to that node. So A is an ancestor node, C is an ancestor node and G is also an ancestor node of the nodes J and K. Can you tell me the ancestor nodes of F? So it is B or A. Okay, you can say A and B are the ancestors of node F. Just opposite is descendant node. So it is any successor node on any path from the node to the leaf. Here the leaf nodes won't contain any descendants. In the given tree, the nodes C, G, J, K, they all are the descendants of node A. Similarly, the descendants of node D is H and I. Okay. The descendant node of C is G, K or G. So these are all called descendant nodes. So with this we have completed the basic terms of tree ADT. We move on to the topic types of trees. The trees are classified into 6 types: general trees, forest, binary tree, binary search tree, expression tree, tournament tree. So general tree is nothing but is a data structure that store the elements in hierarchical manner, and the top node is designated at the root node, and each node except the root node has a parent. Okay, so the normal tree is called as general tree. Then the forest is a disjoint union of trees. So how can you obtain this set means? You can obtain this by deleting the root and its edges connecting the root node to the nodes at level 1. So the given tree is A, B, C like that. how will you obtain the forest? You have to delete the root node and the edges, they are connecting to nodes at level 1. So if you remove this part, then what about the remaining thing? We have 3 disjoint trees, B, C, D, then E, F, G, H. Okay. So they are called as the forest. Then binary tree, it is one type of tree in which each and every node must contain at most 2 children. Okay, for each node you must have at most 2 children. So what about the node of C? For the node C, I am having 2 child F and G. Similarly for node A, B and C are the child node. So if I am having one more child to node A, then it is not a binary tree. Okay. So hope you can understand what is binary tree. Then binary search tree, it is a variation of binary tree. Here we have added one condition. What is the condition means? The left child value of the node should be less than or equal to its parent value. Okay. The left child value should be less than or equal to the parent value. And the right child value, it can be greater than or equal to the parent value. So this is the condition. See, we have the root node 8. In left tree, its left child is 3. So 3 is less than 8. And its right child is 10. So 10 is greater than 8. For the node 3, its left child is 1. So 1 is less than 3 and its right child is 6. 6 is greater than 3. Okay. So this is the condition for binary search tree. For every node, its left child should be less than or equal to its parent and the right child should be greater than or equal to its parent. Okay. So what is called expression tree? It is also a special kind of binary tree. Here each leaf is an operand, whereas the root and the internal nodes are operators. Okay, the internal nodes are operators, but all the leaves are the operands. So this is an example for expression tree. Tournament tree, it is a complete binary tree which contains n external nodes and n-1 internal nodes. Here the external nodes represent the players and the internal node represents the winner of the match between the two players. Okay. So that's about the types of binary tree. So these are some gate questions. They may ask you to calculate the degree of all the vertices in the given tree. Okay. They may ask you to calculate the height of the tree, like that. Okay. So with this, I have completed today's class, the introduction of tree data structure. For more videos, kindly subscribe to Rogini CSE Tech Talk. Thank you.